Next, so interrupts are again classified to, tell me, maskable, non-maskable. So maskable, nothing but programmer control the interrupt. Programmer enable or disable the interrupt is called a maskable. Programmer enable or disable the interrupt. Programmer control the interrupt. Programmatically or enable or disable the interrupt. That is called what? Maskable. Non-maskable, nothing but programmer unable to control. The programmer control the interrupt. That is called a maskable interrupt only. So write a program, enable or disable the interrupt only. Maskable. Non-maskable, nothing but programmer unable to control the interrupt only. Trap is a non-maskable. Trap is a non-maskable only. Trap is interrupt now. Non-maskable. So the meaning of maskable, programmer control the interrupt. Programmer, how to control? Enable or disable. Write a program, disable the interrupt. Write a program, enable the interrupt. Programmatically. Okay, write a program. The program you're controlling on it. For example, I am decide, I want disable this interrupt. Disable. I want enable interrupt. Enable. You understand the maskable? I tell you simple example only. So I begin the class. Phone call is a interrupt or not? But this is a, I want put the maskable. The phone call I convert the what? Tell me maskable. So definitely I can put a silent mode. I put a what? Silent. The meaning of silent mode, disable the interrupt. Disable the what? Interrupt. The meaning of silent mode, I'm not interested to what? Accept. This phone call interrupt is a maskable. What tell me? Maskable. The meaning of maskable, I disable. So whenever I want switch off also, even you are didn't get, okay. If you enable the phone call, enable right now the enable mode only. Now I can able to receive or not? You understand? No? You understood the maskable nothing but you are disable, okay. But some of the non-maskable no. The non-maskable nothing but we cannot, programmer cannot control. Definitely. Okay, because somebody knocked the door. That is not my hand. Tell me, I can't, maybe understood no. Somebody knocked the door. Even I put the lock the door also. But somebody what knocked the door. Unexpected no. I can't control. That is called mean non-maskable. I can't control some interrupts on the programmer. I am take the class only. I can control some interrupt. Before start the class now, I can control something. Disable the mobile phone. Something I can do. Okay, but everything I can't do. Okay, some is what? Non-maskable. So non-maskable interrupt only. So non-maskable interrupt is a only one interrupt is there. Which one? Tell me. Trap. In the trap is a called a non-maskable interrupt. NMI. Shortcut is called NMI. Everyone pronounce it NMI now. Trap is also called a NMI. Non-maskable interrupt. Every microprocessor at least one NMI compulsory. NMI. Okay. But NMI is a very critical situation actually. Why NMI? What is the reason NMI? For example, the smoke detector sensor, smoke sensor. No? Almost everywhere smoke sensor is there. Smoke sensor. The smoke sensor once send the smoke na, because some fire is going on. Smoke sensing on. Once send the smoke, the sensor raise the interrupt. The device raising a interrupt. The interrupt is the programmer unable to disable because they're very critical or not. There's no chance. You don't give the programmer to disable the interrupt only. Programmer by mistake disable the smoke sensor interrupt. Dangerous or not? So understand no? That type of interrupts now we give the NMI. Give the what? NMI. So the programmer don't give a chance to the controlling only. Programmer by mistake disable it now programmatically. They are missing a lot of things or not? Dangerous. Okay. The very critical kind of the devices now. You are using which one? Tell me. Non-maskable interrupt. Programmer unable to control it all. The programmer definitely he can handle the interrupt at any situation. Stop the program, go and take it now at any scenario. That is called what? Non-maskable interrupt on now. Non-maskable. So maskable is your phone call I am enable disabling, but programmer we have one bit is there, bit flag like that. Write the value 1, interrupt enable. Write the value 0, interrupt disable. Here my phone call just to the option like that. The programmer your job is just 0 or 1. That's why bitwise operators are very important. They are going to write the 0 flag register like that. You know flag no? 0 like a 1. 0 is a phone is a interrupt is a disable. 1 is the interrupt is enable. Understood no? 0 is a disable. 1 is a what? enable. Something. Write down, no, the programmer write down, okay? You want enable or disabling one. Okay, no, you can see, no, it is there actual maskable interrupt on now. So tomorrow also discuss now. In our 8085 microprocessor, okay, set SIM is there, set interrupt maskable, SIM. SIM is a, no, one register is there, no, SIM, the instruction actually. For example, you can see now, the bit number, no, see the one. Bit number 0, can see. Bit number 0 is a RHT, the 5.5. Bit number 1 is a RHT, the 6.5. Bit number 2 is a RHT, tell me, 7.5. So you can see 5.5, 6.5, 7.5, both are maskable interrupt. Both are which interrupt? Maskable interrupt on it. So programmer controlled the three things on it, the three. Okay, INTR also maskable on it. INTR software interrupt also maskable on it. You all maskable on it. Maskable. How maskable? Tell me. So this register, SIM register, interrupt, no, the enable register. Bit number 0, write the value 1. 5.5 interrupt to enable. Here bit number 1, write the value 1. 6.5 interrupt to enable. Bit number 2, write the value 1. 7.5 interrupt to enable. If all the bits are 0, all the 3 interrupts are disabled. I want enable only 7.5, second bit set only. Remaining 2 are what? 0. Like that, which one you want enable, enable. Which one you want disable, disable. Everything you want enable, enable. Everything you want disable, disable. Whatever you want. Okay. Understood now? So because they all are the call, tell me, all are tell me. Maskable interrupt. First one tell me, non-maskable interrupt only. We are INTR also maskable only. The software interrupt also maskable only. Okay. We have an assembly instruction there. Okay. Now I'm going to cover next. Disable interrupt. Enable is assembly instruction. Tomorrow we'll discuss now. DA is assembly instruction. Disable interrupt. Here is what? Enable interrupt. First of all, you want write down which bit you want to enable, and DA and EA. The assembly instructions are there. They are maskable. No, the interrupts are now maskable. You don't understand? Clear? Okay. So these are major all the interrupt handling on now.